third problem of IMO 2020 International Mathematical Olympiad, the most prestigious math competition in the world. This problem is from combinatorics topic. In combinatorics, we have around 40 ideas, 40 famous ideas that you must learn. One of them is to change the problem to graph, and now we want to see how to use this idea. Problem 3. There are 4n pebbles of weights 1 to 4n. Each pebble is colored in one of n colors, and there are 4 pebbles of each color. Show that we can arrange the pebbles into 2 piles so that the following 2 conditions are both satisfied. The total weights of both piles are the same. Each pile contains 2 pebbles of each color. We start from here. We have n colors. Each color has 4 pebbles, and we define graph G with n vertices. Vertex I corresponds to color I. And if pebble X and pebble Y are like this, and their sum is 4n plus 1, then we connect them, and in our graph we connect vertex I and vertex J. And the graph G is not necessarily a simple graph. We can have multiple edges between 2 vertex, for example, like this, if x and y satisfy the property, and also z and t satisfy this property, then we have 2 edges between these 2 vertex. And also we can have self loop like this if the pair is in a if for example a pair has the same color. And now we consider how many pairs do we have. 1, 4n, 2, 4n minus 1, so we have 2n pairs, and we can conclude we have 2n edges. And since from each color we have 4 pebbles, then we can conclude that each vertex has degree 4. Now if we can choose n edges for pile number 1 so that each vertex has degree 2, then the problem will be solved, because if you choose n edges for pile number 1, then the first condition of the problem will be satisfied, and if each vertex has degree 2 with these n edges, then you can prove that from each color you have 2 pebbles in pile number 1. At first, let's consider this lemma. We have a connected graph G that every vertex has even degree. Prove that we have enclosed Eulerian circuit. What is Eulerian circuit? Eulerian trail is a trail that visits every edge exactly once, allowing for revisiting vertices. An Eulerian circuit is an Eulerian trail that starts and ends on the same vertex. At the end, we will prove this lemma. Let's continue our proof. We defined graph G, and we assume G has k connected components. Let's consider component 1. If it has L vertices, then we can say that the number of edges is 4L over 2 equals 2L, because all the vertex has degree 4. And now by applying lemma, we can say that it has Eulerian circuit, so we can name the edges of our circuit with E1 to E2L consecutively, and we denote them by 1, 2 until the last one is 2, because the number of edges is even. Number of edges are even, and each vertex has degree 2 here with edge number 1, because here we have half of the edge have number 1, and the other half has number 2. And now we want to prove that each vertex has degree 2 with edge number 1. If you consider a vertex like this that has two self loops, then according to the fact that component 1 is connected, then the whole component is just this vertex. You see this 1 and 2, so this vertex has degree 2 with edge number 1, and if this vertex has just one self loop, then you enter past this self loop and exit is 1 to 1 and 2 1 2. The condition satisfied in this case, and also if it has 4 edges like this, you enter exit again, enter and exit. It's 1 2 or vice versa, and 1 2 or vice versa. In this case also the condition will be satisfied, and now we want to prove the problem. So we have n edges with number 1 and n edges with number 2. Each pile, we put all edges with number 1 in pile 1 and the other one in pile 2. The weight of the first pile is n times 4n plus 1, so the first condition will be satisfied, and also we want to prove the second condition. We proved that each vertex has degree 2 with edge number 1, so we have all these 4 cases, and if we consider them, in each case we have 2 pebbles from each color in pile number 1. For example, here these 2, here these 2, these 2, and these 2. The only thing that we must prove is the proof of the lemma. We prove it by induction on E. The base case is E equals 1. Every vertex has even degree and G is connected, so the graph is one self loop, and it's obvious. We assume the sentence for 1 to E minus 1, and we want to prove it for E edges. We start from a point, continue until we visit the vertex that we visited before. So we consider this cycle. Maybe it is a loop, it doesn't differ. By deleting this cycle, you delete from each vertex 0 or 2 edges. So again, in each component, if you consider only red edges, each vertex has even degree. So you can use induction and start from x. Each time you reach to the component for the first time, you can see all the red lines and back to the vertex you start, and again continue through blue lines. Then you can see all the blue lines and red lines. And now the problem has been completely solved. I will upload the rest of the problems in the near future.